Hello everyone. Just wanted to drop a short video to help you through some of these homework sections. The first one here on the rotating sky explorer. If you were not able to download that, I can kind of go through and show you how this works. So on the left I have my homework open. On the right is the rotating sky explorer. And what you can see here is that this is the Earth in space, and the big sphere around it is called the celestial sphere. That's where all the stars are attached. And I've asked you on the homework to add the Big Dipper, Orion, and Southern Cross and the star patterns there, so you can kind of see where they are in space. When you start the animation, it makes the stars move around in your local sky, which is pictured on this side. And you can kind of see as the Earth rotates on this side, the stars are doing their do-si-do through our sky over here. And you can see the Big Dipper is one constellation. It swings low, never sets though. It's called circumpolar. It rises up to the top of the sky and then swings low but never sets. That never set region there, the circumpolar region, is in the red shade there. That's the stars we can see all day and night. Then you can see that the stars that are coming up here on the horizon, I'll move this over here. As the Earth turns toward it, you can start to see Orion, and Orion gets the top part of the sky right there, and then begins to set. And you can see those are a series of rise-set stars. It's of note that the angle that these stars rise and set at are 90 minus your latitude. In Malta, the latitude is 42 degrees, so the stars rise 90 minus 42 or 48 degrees, and they also set that like that. And you can see Orion doing that. I'm asking you to go through and find these different locations and see their rise set angle. Now, of course, you can take 90 minus each of these latitudes to get the answers. That's a hack and a hint there. But you can also go ahead and dial them in. So I'll go ahead and dial them in here. So Malta was 48 degrees for the rise set angle. And if we go to New York at 40 degrees latitude and 74 longitude, that moves our little dot over to New York there. And notice the stars are rising at an angle of 50 degrees off the horizon. Honolulu, Hawaii, let's go there. Wish, what if, right? The longitude there is 157 degrees west longitude, and the latitude 21 degrees north latitude. And at that location, now you can see you're here on the Earth. I have the Earth spin around here. You can see that the rise set angle is now 69 degrees here. And you can kind of see there we are in Hawaii with Orion there. Orion has a really high angle of rise set there. And then if you want to go to Baker Island, which is right on the equator, that's 0 degrees north latitude and 176 degrees west longitude. One of those beautiful islands, U.S. territory in the Pacific. Orion sets directly in the east, rises up to the zenith point or the top of the sky, and sets directly in the west. So the rise set angle there in Baker Island is 90 degrees. What if we went way up to Barrow, Alaska? 71 degrees north here and 156 degrees west. That has our stars rising and setting at a very low angle. Look at that. Wouldn't that be kind of interesting to see the stars come up on the horizon at an angle of 19 degrees? There's Orion peeking up, swinging around the southern horizon, and then boom, sinking back down. Pretty crazy, right? Many more stars are circumpolar here in Barrow, Alaska. If we go to the North Pole at 90 degrees north latitude, now all the stars are circumpolar. You can see there are no stars rising and setting, and the angle of rise set is 0 degrees. So 90 minus your latitude is your general rule for determining. Thanks for watching this section. Okay, everyone, I just wanted to take you through the next part, seasons in the Zodiac. And here's a simulator here from the NAAP labs. First off, it is to note that the 12 constellations of the Zodiac are listed here. They had personal and spiritual meanings for folks in the ancient world, as well as astronomically. What happens is the Earth, because of how it is so close to the sun, and so distant to the other stars, it actually takes 24 hours for the Earth to rotate around one time and get the sun lined back up, because when it does do a 360-degree turn, it actually has to turn another extra degree, like 361 degrees, in order to get back the sun lined back up with the top of our sky at noon. And so this extra 1 degree takes an extra 4 minutes. And as a result, these stars rise 4 minutes earlier every day. And so the sun then will traipse through the zodiac over the course of the year. And as the stars rise 4 minutes earlier every day, the sun at noontime will be in a different zodiac constellation. And so you can kind of see how when you slide the slider, it shows the different dates and when the sun is particularly in that constellation at noontime. So the first part of this says the zodiac constellations lie along the ecliptic, and it goes on and it asks how many degrees of lag does the sun have behind the stars? And the answer here is 1 degree per day. All right. I'm then going to ask you to go in and type in your birthday and your zodiac sign. And when you do that, you're going to come to this slider and see where the sun is. Now, my birthday is September 2nd, and my astrological sign is Virgo then. So I'm going to click and drag this slider over to September 2nd. And there's an interesting problem here. The sun is in Leo at noontime on my birthday. So I'm a Leo. I'm not a Virgo. I'm an astronomical Leo, but I'm an astrological Virgo. How is that? Well, I can go through and give you an explanation that the Earth has a wobble as it spins on its axis. It's called precession. And because of this, our view of the stars change over time. When the zodiac was made by the Babylonians 6,000 years ago, the Earth was pointed at the Earth's North Star was pointed at a different location of the sky. Now, as it's wobbled 6,000 years later, it's now pointing at Polaris, and the view of the stars has changed since the zodiac was made. So I want you to see if your astrological sign is different from your astronomical sign. Okay, so that's the goal here. So I'm gonna just kind of show you all the way through here. So if you're early January, your birthday is in early January, it's Sagittarius. Mid-January, Capricorn. Early February, Capricorn. Mid-February, Aquarius. Early March, Aquarius. Mid-March, Pisces. If your birthday is in late March, Pisces, through mid-April, Pisces, and then it's not until late April you'd be Aries. And Aries would be through mid-May, and then in mid-May you turn into a Taurus. And you'd be a Taurus in mid-May all the way through to mid-June. And in mid-June, then you'd become Gemini. And Gemini would take you through mid-July. And then if you're in mid-July to late July, you'd be Cancer. And Cancer takes you through to early August, and then you become Leo. And you're still Leo all the way through till about mid-September. And then in mid-September, that's when you become Virgo, and that'll take you through, you'll be a Virgo all the way through till you get to about the beginning of November. And then once the beginning of November, you're a Libra, and then to mid-November, and then mid-November through mid-December, you're Scorpius. And then from there, you're Sagittarius. So very interesting. See where your birthday falls and go ahead and write in where the actual sun lies during your birthday and see if there's a difference. Okay, the next section of the homework deals with motions of the sun and the simulator here. It asks you to dial up Malta here in the latitude and the day of the year being summer solstice, June 21st. Down here, the information shows all the information about the particular sun position at that given time, and including the altitude of the sun, the azimuth, the latitude that you're in and the date and time. The first set of questions here asks you to find the time of the sun rising in Malta. So what I'm going to do is I'm going to drag the sun down to the eastern horizon, and note that in the summertime the sun rises really in the northeast. That's interesting, right? And the general rise time of the sun is right about uh, 4:30 a.m. So that's the general rise time for a place like Malta. So very interesting. So 4:30 a.m. In what direction along the horizon, north, southeast, etc., does the sun rise? Okay, so you can see here what direction that is. You write that in for number 25. Click and hold and drag the sun so it is around the highest point in the sky. This is local noon for Malta, so that's where we started actually. We'll drag the sun back there. And this is local noon. What's the sun's altitude in Malta around noon? And the altitude is down here for that. Now click and hold and drag the sun to the western horizon. So let's do that. Bring it down here. Notice it sets there in the northwest, right at about around 7:30 p.m. All right, about how long is the sun in the sky during, you're going to have to do the math for that one. And in what direction along the horizon does the sun set? You can see that pictured here. Okay, now we're going to move to December 21st in Malta. So I'm just going to change this to December. We're going to see quite a different picture here. First, what time does the sun rise? So let's get the sun back rising here. Okay, and here's the sunrise. Notice that you have north, south, east, and west. The sun's rising here all the way down to the southeast. Remember, in the summer it rose over here, so that's pretty interesting, right? And the general rise time for the sun is 7:30 a.m. Click and hold and drag the sun to its highest point. Okay, this is local noon. What's the sun's altitude around noon? And the sun's altitude down here about 24.5. What's the difference at noon in June versus noon in December? So you're going to have to write that in there as well. Now I'm going to click and hold and drag the sun so it's the western horizon here. Notice how the sun doesn't really get up very far. Look at how long the shadow is. And then boom, it's setting here at about 4:30 p.m. What time does the sun 4:30 p.m. in what direction along the horizon? And there it is, the southwest, right? Setting in the southwest. How long is the sun in the sky in Malta? So you're going to do the math for that. And what is the ultimate cause for the differences in altitude of the sun? And that's probably going to be Earth's rotation, right? Earth's tilt. The fact that during the summertime we're tilted towards the sun, and when we go over another half a year, we end up being tilted away from the sun, and that huge difference, that 23.5 degrees tilt towards the sun, and then the 23.5 degree tilt away from the sun, creates quite a different sunrise and sunset position each time. So that's it for this section. Okay, the last section of the homework that you need to use these explorers with is the HR diagram explorer, which you see pictured here on the right. And some things to note about this, that this is a plot of stars. So stars will fall on different parts of the HR diagram based on their life cycle and their size and so forth. The HR diagram gives the energy output or luminosity here along the y-axis here. More luminous stars, in other words, stars with greater energy output are higher on the diagram, and stars with lower energy output are lower on the diagram. Actually, luminosity is directly related to magnitude, so you can actually switch that scale. Magnitude is the brightness of a star. Brighter stars are higher on the HR diagram, and dimmer stars are lower on the HR diagram. Temperature is also listed here. Temperature is on the x-axis. The hotter the temperature, the farther to the left it is. The cooler the temperature, the further to the right it is. And it gives lots of neat things, like it shows you the different types of stars. White dwarfs usually are in this section of the HR diagram. Supergiants are up usually in this section. Red giant and red supergiants up here. Dwarf stars and kind of like the main sequence stars right here along this area. You can also do some pretty neat things with this diagram. So in the cursor properties, it shows you the temperature and the luminosity here. You can actually drag this to make the temperature go lower or higher, and notice the sun is the other star here for comparison. And then you can click reset here. Luminosity, that's the energy output. The lower it is, the lower you are in the diagram. The higher it is, the higher it is up here. And then magnitude is another one here. If you click magnitude, you'll get the brighter stars are higher and the dimmer stars are lower. Okay. And that's pretty much it. All you really need to know for this section. You got the hot stars are found where? Well, if you look at the diagram here, you can see that. Faint stars, which are a magnitude issue, the lower the lower the brightness, the more positive the magnitude. So faint stars would be more down this way. Of course, there's the cool stars, luminous stars. We'll go back to the luminosity for a moment. Okay, that's the luminosity. It doesn't matter if you're here or here, it's just always luminous. This might control the color of the star, but it's all still very luminous. Reset that. Let's see your small red stars. Where we find those? The red stars are over on the right because they're cooler, and smaller is down this way. The little radius of the sun or solar radii here, or the green lines, are kind of like showing you that bigger stars are found this way on the diagram and smaller stars found this way, right? So with what I've just gone through, hopefully you can get a better sense of the answers to the questions on this section of the homework. So use this part to help you.